Welcome everyone to part 5 of the Sci-Fi first-person shooter tutorial series. In this video, it's an important one. We'll be creating 3 different firing modes for our character: semi-automatic, 3-round burst, and fully automatic. Each of these modes will have different projectile pitches, sizes, decal sizes, and damage. And we'll be driving our current firing mode with an enumeration variable. So let's get into it. First, we'll need to open our master FPS character blueprint, and we'll be setting up all of the firing functionality here in the event graph. Right now, we're firing our projectile only when we hit the input action fire, which is set up to be left click in our project settings, but we'll want to make the actual firing of our projectile its own event in case we want to call it any other time than when we hit that input action fire button, like if our character gets scared, or if the gun malfunctions, or literally any other time than when we click the left mouse button. So let's make a custom event by right-clicking on the event graph and searching for custom event. We'll go ahead and call this fire weapon so that we can call this function anytime we actually want to fire our weapon. And instead of having our input action fire plug directly into our spawn actor, we're going to have our fire weapon plug into our spawn actor instead, and we'll just move our input action fire out of this comment box. Let's straighten this up just a little bit, give us some space, and compile and save. So now whenever our fire weapon event is called, that is when we will spawn our actor for our master projectile. With that being said, we can search for the fire weapon custom event and call that function whenever we use our input action fire. So we get the same result we had before. We'll still fire our projectile, but we'll be calling this function whenever we hit this event. So basically when we left click, we still fire our projectile. Setting it up this way also allows us to call the fire weapon custom event, or function as it is here, whenever we want from this actor or any other blueprints referencing this actor, giving us just a little bit more control over when our weapon fires. Next, we should make sure that our weapon fires only when our character is alive. So if we attempt to fire our weapon but our character's dead, nothing will happen. And in order to do that, we'll have to set up a health system. Now we haven't set up any health for our master FPS character yet, but we can do that very easily by creating a variable to keep track of our current health. In the My Blueprints tab, we can create a new variable under Variables just by clicking the plus button. Let's click that button and name the variable health. It will automatically create a boolean by default, which is a true or false value, but that won't really help us in keeping track of our health value. So in the details panel on the right hand side, we can change the type of variable by selecting the current variable type and expanding the dropdown. There are really only 2 good options that we can use to keep track of our health: an integer and a float. These are 2 types of variables that store a number value, which we can use to keep track of our current health. I like using floats because Unreal's built-in damage system also uses floats, so it's much easier to use with that type of variable. So let's select float from the dropdown, and once you compile and save, the default value for the float will be 0. But we'll want to start the game with full health, so let's change the float's default value to 1.0. Another reason I prefer floats over integers in most cases is because a float can hold values between whole numbers, which makes it easy to use a float as a percentage, where 1.0 would be 100%, 0.5 would be 50%, and 0.0 would be 0%. If we were to use an integer for our health value, we'd need 2 variables actually, one to store our current health value, and we'd need another variable to store our maximum health value. Both of these values can be stored in a single float variable if you're using it as a percentage. The only caveat really being if you're making an RPG or a type of game like that where your maximum health increases throughout the course of the game, you may actually want to use an integer so you can increase the maximum health variable based on a character's level or stats. It's more difficult to keep track of an increased maximum health by using a single float variable, so definitely think about using integers in that case instead. Anyways, we want to check to see if our health is above 0 to make sure our character is alive before we fire our weapon, so that when our character is dead, they won't be firing their weapon. Let's get our health value at the beginning of our fire weapon custom event. And let's drag off of it and search for the greater than check, float greater than float. And we're going to check to see if our current health value is greater than 0.0. And we're going to grab this Boolean return value and plug it into a branch node. Now you can search for branch, or to make it faster, you can just search for an if. That'll automatically pull up branch for you. This will allow us to spawn our projectile only when we're alive if we plug in the spawn actor to our true path. In fact, we're going to be checking if our character is alive a lot throughout the tutorial series, so let's make this a pure function by selecting these two nodes, right-clicking, and collapsing them to a function. That will make them a normal function, but we can actually turn them into a pure function by checking this box, the pure box, and making it true. We're able to make this a pure function because it's not setting any values, it's just retrieving information. Let's rename this function to isAlive ? And for the return value, we'll just change the name to alive. So we can quickly check to see if our character is alive at any time by using this function and plugging it into a branch. Now that we've determined if our character is alive, the next thing we need to do is find out what firing mode we're currently in. Now there's a few ways that we could do this, like creating a couple Boolean variables to determine what firing mode we're in and create some linking branches, but that doesn't really allow you to change the firing mode if the variables are instance editable. It doesn't easily allow you to add additional firing modes. It's pretty confusing if you step away from the project and come back to it after a few weeks. And lastly, it's really ugly on the event graph and can get out of hand. So the best method I've found is to not use this. So let's go ahead and delete these. And instead, we can use something called a user-defined enumeration variable, and using that to make a switch node. If you've never used enumerations before, this will be immensely helpful to you now and in the future, so definitely pay attention to this next part. First, we'll need to create a user-defined enumeration, and we do this in the content browser. I'll quickly make a folder called enums just so we can go ahead and put the enumeration inside, create that, and once we're inside the folder, we'll right click. Let's go to the Blueprints tab and select Enumeration. We'll name this enumeration UE4 Enumeration _ Fire Modes. And don't forget to change the color, set the color of our folder to the color of the enumeration, just to keep ourselves nice and organized. Let's open up our enumeration fire modes, and there are currently no enumerators, but we can create our own. The enumerators will be our firing modes that we'll be able to define in the switch. If this isn't making sense quite yet, you'll be able to see what creating an enumerator does very shortly. To make it even more clear on what an enumerator does, I'm currently only going to create 2. To do so, I'll click on New here on the top right twice to make 2. And the first enumerator I'm going to call Semi-Automatic. Let's call the second enumerator Burst Mode. And with these created, we can go back to our master FPS character and add a new variable. Let's click on the plus variable button and we'll call this variable current fire mode. And for the variable type, we're going to make it type E_fire modes, the enumeration that we just made. Now we can compile and save. So the default value of our E_fire modes will always be the topmost enumerator unless you change it here in the default value. Let's get the current fire mode variable, drag it into the event graph and select get, and off of it we can search for a switch on E_fire modes. Plug that into the true path. And this creates something very similar to the branch over here on the left, but instead of the true and false path, we have 2 paths based on our enumerators, the semi-automatic path and the burst path. So whenever we call the switch, we'll execute the path that's equal to our current fire mode enumeration. And here's where the real power of enumerations come from. If we go back to our enumeration and create a third enumerator, let's just call this one automatic, and we go back to our master FPS character, we'll see a third path, so that now we can do something if our current fire mode is automatic. This allows us to have different things happen when we fire our gun based on our current fire mode, and we can add even more enumerators if we'd like, but for this tutorial series I'm only going to have the 3. Now we can go ahead and save our enumeration and close it, since we won't be changing it anymore. Now that we have branching paths and we can determine how we're going to fire our gun based on our current fire mode, we'll need an easy way to spawn our projectile and customize its parameters. So let's highlight our spawn actor blueprint and everything that's attached to it, and we'll right click and create a function out of it. That way it fits nice and neatly on the event graph. And we're just going to rename it to something simple like fire single projectile, so that whenever we want to fire a single projectile, we can just call this function. And I'm going to plug that right into our semi-automatic fire mode. Let's open up our fire single projectile, and it looks like the function's kind of all over the place. Not neat at all. I'm going to get that right in the center here. Compile and save. First off, let's change the collision handling override from what it currently is to always spawn ignore collisions. That way our projectile will spawn regardless if you're close to a wall or close to the floor, anything like that. And at this point, the real benefit of making this a function is so that we can set the parameters of our projectile using inputs for the function. An easy way to create inputs is to drag off of the base damage and put the pin right on top of the function node. We can do that for our base damage and our decal size. When you click on the node itself, you'll be able to see the inputs on the details panel, and I'm going to change the name of size to decal size. We can also change the defaults for these values. I'm going to change the damage to the 0.34, and the decal size, let's change it to something like 40. Now whenever this function is called, these values will automatically be set in the function node itself, and you can manually change them if you'd like. We'll also want to create a peer function for our projectile spawn location and rotation to keep us organized and allow us to override it later on for our enemies. Let's select everything that determines our spawn transform except for the make transform itself, and we can select collapse to function. Since once again this isn't setting any values, we are able to convert it to a peer function. And we can rename it to something like get projectile spawn location. And we can rename these outputs location for the vector and rotation for the rotator. I'm going to eliminate this make transform as well to remove that extra step, since we can plug these directly into the spawn transform if we split the struct pin. Now we can disconnect these and plug them directly into the spawn location and spawn rotation respectively. We'll want to be able to customize our scale for each spawn projectile, so let's drag this pin and create an input out of it as well. Select the node and we can bring it to the top just by hitting the up button twice. And we can use this as the default value, the 0.25, 0.03, and 0.03. And compile and save. Now we can delete the transform node. And I'm going to close these drop downs really fast. And we won't want the volume of each projectile to be exactly the same either, so let's drag off of the volume multiplier and we can select a random float in range. I'll make the values pretty low, like a minimum value of 0.4 and a maximum value of 0.6. because the sound we're using is already very loud. In fact, let's do this for our pitch too. We'll plug our pitch multiplier into here, except we'll have the min and max values be inputs for our function as well. So let's plug these right into the node, drag down this function, and make it a little bit neater. We're going to have a lot of crossing wires for this, but it should work out in the end. We're going to change the name here. It's going to be min pitch, and let's change it to max pitch. For our default values for minimum pitch and maximum pitch, I'm just going to change them both to 1. We can customize those values based on our firing mode later on. Now we have a ton of parameters for the projectile being determined when we fire this function. If we return to our event graph, we can see that our fire single projectile function and all of its inputs are available whenever we fire it on semi-automatic mode. And at this point, we can determine what we do based on our current firing mode. For semi-automatic, it's pretty simple. We're just going to fire our single projectile once. And that's really it for semi-automatic, since all we really want to do is fire a single projectile when we fire a weapon in this mode. But we can customize some of these parameters. In fact, let's make it like a 5-shot kill, since we'll be able to spam projectiles in this fire mode. So I'll change the base damage instead of a 3-shot kill to a 5-shot kill with a value of 0.2. And maybe I'll change the maximum pitch to 1.4 just for some variation. And let's make the decal just a little bit smaller, something like 30, hence the less damage that it does. Now we'll move on to burst fire, something a little bit more complex. First, we'll need a Boolean variable so that we don't spam the burst mode and end up firing more than 3 projectiles in quick succession. So let's create a new variable and let's change it to a Boolean. Now we can rename this to cooling down ? Compile and save, and by default we'll want the value to be false since we won't be cooling down as soon as the game starts. We're going to wait until we fire to begin cooling down. Now let's drag cooling down into the event graph, get cooling down, do a branch node, and plug that into burst mode. So the first thing we're going to do is check to see if we are currently cooling down. On the false path, we're actually going to set cooling down to true, so that we're cooling down as soon as that check is done. This prevents the path from being executed again until the burst is completed. After cooling down is set to true, we'll want to fire a single projectile, and we can customize the parameters of this projectile here on the function. We can keep most of these values to the default, but since we're doing a little bit more damage, we might want to change the scale to something a little bit bigger, like 0.4, and then 0.04 and 0.04. Let's change the minimum pitch from 1.0 to 0.9 and the maximum pitch to 1.1, just for some more variation in pitch. After this projectile is fired, we'll want to delay for just a split second. Let's do maybe a 1/10 of a second delay before we fire another projectile. Let's copy both of these, Control-C and Control-V. Let's paste it twice so that we have a 3-round burst, and plug in the executes. Drag out the comment box. And now you can see we will fire a projectile, wait 1/10 of a second, fire another, wait another 1/10 of a second, and fire another. For this last delay, we're going to wait maybe about a 1/2 a second so that we have about a 1/2 a second cooldown before we are done cooling down, and set our cooling down Boolean variable to false. Let's quickly test out both of our firing modes by creating some input logic in our input graph. Let's double click on our input graph to open it up, scroll down to give ourselves a little bit of space, and we can right click and search for whatever keys you would like to use to change the firing mode. I will be using keyboard 1, keyboard 2, and keyboard 3. I'm going to line them up nice and neat, move them over to the side, and zoom in a little bit, compile and save. From these events, we'll simply need to change our current fire mode. I'm going to copy and paste twice and plug it into the pressed. For number 2, I'm going to change it to burst mode, and number 3, change it to automatic. So that'll be a simple way to change our current firing mode. Let's hit the back button to go back to our event graph. Now we can minimize our blueprint, hit play, and whenever we fire, we'll automatically be in our single shot mode, semi-automatic, so we can spam it as much as we want. Let me do it real fast. But it only does 1/5 of the maximum health of someone that it hits. If we hit the 2 button on our keyboard, we will be in 3-round burst mode. And these will do 34% of the maximum health of whoever it hits. Alright, so let's go back to our master first-person character, and we can move our input action fire down just to give us a little bit more space, since we will need it for our automatic firing mode. And once again, we'll want to ensure that this firing mode isn't spammed, so we'll reuse our cooling down check, Control-C, Control-V, and we'll also need to create a new boolean called firing weapon. So let's click the plus variable, and we'll call this one firing weapon, ? Compile and save. This default value will also stay as false. On the automatic path for our switch, we'll want to set firing weapon to true, since we will be firing our weapon if we hit the input button and firing our weapon in automatic mode. Plug that into the branch and neaten that up a little bit. After cooling down is set to true, we can fire another single projectile with whatever customizations we want to set. I'm going to expand this comment box a little bit. And I'm thinking that I'll make these the largest and hardest hitting projectiles of all the firing modes, almost like a turret but with a very slow rate of fire. So let's change the scale to something huge like 0.6, 0.06, 0.06. The base damage can be something like 60% so that it's definitely a one-hit kill. The decal size, we can make it something huge like 80. And then the pitch, we want it to be a little bit deeper since it's a bigger bullet, so we'll do a minimum of 0.7 with a maximum of 0.85. From here, we'll want a small delay before the next shot is fired, so I'll right-click, type in delay, and plug in the executes. I'm going to wait about a quarter of a second. Once this delay is completed, we can change cooling down to false, so that we know we're no longer cooling down. And lastly, we'll make a branch to see if we're still firing our weapon and if we're still alive. To do this, we'll drag off our isAlive function and we'll get our firing weapon, get firing weapon. In fact, I'm going to swap their positions here. And we're going to need to check if both of these are true. So we'll drag off of firing weapon, search for an and boolean, and plug in alive. And then off of the and, search for a branch node, and plug that into the branch. So if both of these are true, true will be our execute path. And what we'll want to do if we are still firing and if we're still alive, we'll want to bring this all the way back to our branch node here. To make it a little bit easier to find out what's going on, we can do a reroute node and just move it up here just so you can see the path that this is taking. Since the true path will always loop this code over and over, that means that we'll continue firing our projectile every quarter second until our character either dies or until firing weapon is set to false. Which means that we need a way to set firing weapon to false so that we stop firing our weapon. We should probably do this when the player releases the fire button, so let's go to our input action fire, move it off of the comment box, and when this button is released, we can set firing weapon to false. Compile and save. With that done, we have 3 unique firing modes that our master first-person shooter character and all of its children that we'll later create can utilize. If this event graph looks too messy for you, you can always collapse these executes down into macros by right-clicking on them and select collapse to macro, but I'm going to leave it like this on my event graph in case anyone needs to reference it in the future during the videos. And just for demonstration purposes, let me go ahead and play in the editor so that you can see these 3 firing modes in action. I have the single shot, which I can spam non-stop, but it's barely dealing any damage. I can do my 3-round burst, which if all 3 rounds hit someone, they will die immediately. And if I hit number 3, I have my gigantic automatic firing mode that's leaving huge decals and dealing a ton of damage to anyone that it hits. I can't spam the 3-round burst or the automatic due to my cooldown checks. Alright, so let's go back to the master FPS character and let's quickly organize all the variables and functions that we made to keep our project nice and tidy. I'll select my current fire mode, and before I forget, let's change this to instance editable by clicking this here, or you can change it to instance editable by clicking this here, compile and save, and we're going to create a new category for the current fire mode. Let's call it weapon parameters. Let's also put the cooling down and firing weapon variables into the weapon parameters as well. Let's also create a new category for our health called character parameters. And we can put our base turn rate and our base lookup rate in there as well. I'm going to put health on top, compile and save. We actually don't need our gun offset variable. It's currently being used in our get projectile spawn location function, but we can optimize that function so we don't need to use this variable. Let's open it up and remember that this function determines where our projectile spawns, but it basically uses our sphere component to do this. Let's rename our sphere component to spawn target so that we can remember exactly what that component is being used for. And instead of using the gun offset in our function, we can directly plug in the spawn target get world location to the location, and we can continue using the first person get world rotation for our rotation. So we can delete these here and just move these down to make it nice and neat. Very nice. Now, if we go to our viewport and we select our spawn target, we have set it up so that wherever this component is, that is exactly where our projectile will spawn. And we'll eventually end up moving this spawn target so that we're not hit with our own projectiles. At this point, we can delete our gun offset variable since we are not using that variable anywhere else. And for the functions that we made during this video, we can create two new categories. For the isAlive function, we can create a category called character, since it corresponds to our character. And for the projectiles, we can create a category called projectile, and put both fire single projectile and get projectile spawn location into that category. Alright, well that leaves us in a great spot to end the video. Thank you so much for following along and hopefully learning something along the way. I love making these videos and doing my best to help the community. In the next video, we'll be implementing a damage event for our character. We'll also create a death event, a despawn event, and we'll even get started on a game over event. So it should be a good one. Don't forget to like, comment, and subscribe, all that YouTube support stuff. I'm Jovan D, here to help you think like a game developer. Stay tuned for the next video in the first-person shooter tutorial series.